SE cable, when used to supply appliances, must adhere to specific temperature limitations based on its insulation type. It is crucial to understand these limitations to ensure safe and compliant electrical installations, particularly in areas with existing ranges or electric heating. The National Electrical Code, or NEC, dictates these requirements. When dealing with SE cable having type RHW-2 insulation, the maximum allowable temperature is 75 degrees Celsius, equivalent to 167 degrees Fahrenheit. This temperature rating signifies the highest temperature the cable can safely withstand during continuous operation without degrading its insulation properties. Exceeding this temperature can lead to insulation breakdown, posing a significant risk of electrical shorts, fires, and other hazards. For SE cable utilizing type THWN-2 insulation, a higher temperature limit is permitted. This type of insulation is rated for up to 90 degrees Celsius, which translates to 194 degrees Fahrenheit. The higher temperature rating of THWN-2 insulation allows for greater flexibility in applications where the cable may be exposed to elevated temperatures. However, it's important to always verify the specific temperature rating marked in the cable itself, as variations may exist. Several factors can contribute to the temperature rise of SE cable in appliance applications. Firstly, the ambient temperature of the surrounding environment plays a crucial role. In areas with high ambient temperatures, such as near ranges or electric heaters, the cable's temperature will naturally be higher. Secondly, the amount of current flowing through the cable, or amperage, directly affects its temperature. Higher currents generate more heat due to the resistance of the cable's conductors. Thirdly, the presence of other heat-generating equipment in close proximity to the cable can also contribute to temperature increases. It is essential to consider these factors when selecting and installing SE cable for appliance applications. To ensure compliance with temperature limitations, several best practices should be followed. Firstly, always select the appropriate type of SE cable with a temperature rating suitable for the anticipated operating conditions. In areas with high ambient temperatures or high current loads, THWN-2 insulation may be the preferred choice. Secondly, ensure proper ventilation around the cable to dissipate heat effectively. Avoid bundling cables tightly together, as this can restrict airflow and increase temperatures. Thirdly, regularly inspect the cable for any signs of overheating or damage, such as discoloration, cracking, or melting of the insulation. If any such signs are observed, the cable should be replaced immediately by a qualified electrician. In addition to these general guidelines, specific requirements outlined in NEC must be adhered to. The NEC provides detailed information on ampacity ratings for various types of cables at different temperatures. For example, NEC Table 310.16 provides ampacity ratings for conductors based on insulation type and temperature rating. It is crucial to consult this table to ensure that the selected cable has an ampacity rating sufficient to handle the anticipated current load at the operating temperature. Furthermore, the NEC addresses the installation of cables in specific environments, such as those exposed to physical damage or corrosive substances. Article 338 of the NEC specifically covers service entrance cable, including SE cable. This article outlines the requirements for installation, support, and protection of SE cable. It is imperative to familiarize oneself with the relevant sections of Article 338 to ensure compliance with all applicable requirements. When dealing with existing ranges or electric heating, special attention should be paid to the potential for elevated temperatures. These appliances often generate significant amounts of heat, which can impact the temperature of nearby cables. In such cases, it may be necessary to use cables with higher temperature ratings or to provide additional insulation or shielding to protect the cables from excessive heat. It is also important to ensure that the appliances themselves are properly installed and maintained to minimize heat generation. Defective or malfunctioning appliances can generate excessive heat, posing a risk to surrounding cables and other electrical components. Therefore, regular maintenance and inspections of appliances are essential. In summary, understanding and adhering to temperature limitations for SE cable used to supply appliances is crucial for ensuring safe and compliant electrical installations. By selecting the appropriate type of cable, providing proper ventilation, regularly inspecting the cable, and complying with the NEC requirements, the risk of electrical hazards can be significantly reduced. Remember that SE cable with RHW-2 insulation has a temperature limit of 75 degrees Celsius or 167 degrees Fahrenheit, while SE cable with THWN-2 insulation has a temperature limit of 90 degrees Celsius or 194 degrees Fahrenheit. Always verify the specific temperature rating marked on the cable and consult the NEC for detailed requirements. The selection of SE cable depends on the application, encompassing considerations of conductor material, insulation type, and cable construction. Common conductor materials include copper and aluminum, each offering distinct advantages. Copper boasts superior conductivity and corrosion resistance, while aluminum presents a more cost-effective alternative, albeit with a slightly reduced conductivity. Insulation materials such as RHW-2 and THWN-2 play a pivotal role in determining the cable's temperature rating and suitability for diverse environments. Cable construction involves the arrangement of conductors, insulation, and outer jacketing, influencing flexibility, durability, and resistance to environmental factors. Installation practices significantly impact the long-term performance and safety of SE cable. Proper support and securing methods prevent strain and potential damage to the cable, ensuring reliable operation. Adequate spacing between cables facilitates heat dissipation, mitigating the risk of overheating, especially in high-current applications. The avoidance of sharp bends and kinks minimizes stress on the conductors and insulation, preserving the cable's integrity. Furthermore, adherence to local electrical codes and regulations is paramount, guaranteeing compliance with established safety standards and promoting consistent installation practices. Maintenance procedures contribute to the prolonged lifespan and dependability of SE cable. Regular inspections for signs of wear, damage, or deterioration enable timely identification and resolution of potential issues. Cleaning the cable to remove dirt, dust, and debris prevents insulation breakdown and maintains optimal performance. Tightening connections ensures secure electrical contact, minimizing the risk of arcing and overheating. Promptly repairing any damage, such as cuts, abrasions, or exposed conductors, prevents electrical hazards and maintains the cable's protective properties. Troubleshooting techniques aid in identifying and resolving issues that may arise during the operation of SE cable systems. Identifying the specific problem through careful observation and testing is the first step in the troubleshooting process. Using appropriate tools and equipment such as multimeters and cable testers enables accurate diagnosis of electrical parameters. Isolating the faulty component or section of cable facilitates targeted repairs, minimizing downtime and ensuring efficient problem resolution. Replacing damaged components or sections of cable restores the system's functionality and prevents recurrence of the issue. Common applications of SE cable include residential wiring, commercial buildings, and industrial facilities. In residential settings, SE cable serves as the primary power supply for various appliances, lighting fixtures, and electrical outlets. Commercial buildings utilize SE cable for powering lighting systems, HVAC equipment, and other essential electrical loads. Industrial facilities rely on SE cable for powering heavy machinery, production equipment, and complex electrical systems. Different types of SE cable cater to specific applications, each designed to meet unique performance requirements. Service entrance cable, identified by its designation SE, is used to connect the utility power supply to the building's electrical panel. Underground feeder cable, designated as UF, is designed for direct burial applications, providing power to remote structures or outdoor equipment. Mobile home feeder cable, designated as MHF, is specifically designed for use in mobile homes, meeting stringent safety standards for this unique application. SE cable with RHW-2 insulation is a specific type of service entrance cable that utilizes RHW-2 insulation material. RHW-2 insulation is a cross-linked polyethylene XLPE material known for its excellent moisture and heat resistance properties. This type of cable is commonly used for residential and commercial applications where a durable and reliable power supply is required. SC cable with THWN-2 insulation is another type of service entrance cable that utilizes THWN-2 insulation material. THWN-2 insulation is a thermoplastic high-water resistant nylon-coated material known for its excellent resistance to moisture, heat, and oil. This type of cable is commonly used in applications where the cable may be exposed to harsh environmental conditions, such as in industrial or outdoor settings. The ampacity of SC cable refers to its current carrying capacity, which is the maximum amount of electrical current that the cable can safely conduct without exceeding its temperature rating. The ampacity of SC cable is determined by several factors, including the conductor size, insulation type, and ambient temperature. NEC Table 310.16 provides ampacity ratings for various types of conductors based on their insulation type and temperature rating. It is crucial to select SC cable with an ampacity rating that is sufficient to handle the anticipated current load of the circuit it is serving. The voltage rating of SC cable refers to the maximum voltage that the cable can safely withstand without experiencing insulation breakdown. The voltage rating of SC cable is typically 600 volts, which is suitable for most residential and commercial applications. It is important to ensure that the voltage rating of the SC cable is compatible with the voltage of the electrical system it is being used in. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years and is widely adopted by jurisdictions throughout the United States. Article 338 of the NEC specifically covers service entrance cable, including SC cable. This article outlines the requirements for installation, support, and protection of SC cable. It is imperative to familiarize oneself with the relevant sections of Article 338 to ensure compliance with all applicable requirements. Temperature correction factors are used to adjust the ampacity of SC cable when it is installed in environments with ambient temperatures that are different from the standard temperature of 30 degrees Celsius or 86 degrees Fahrenheit. When the ambient temperature is higher than 30 degrees Celsius, the ampacity of the SC cable must be reduced to account for the increased heat. Conversely, when the ambient temperature is lower than 30 degrees Celsius, the ampacity of the SC cable can be increased. Temperature correction factors are provided in NEC Table 310.16. Voltage drop is the decrease in voltage that occurs along the length of an electrical conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. To minimize voltage drop, it is important to select SC cable with a conductor size that is large enough to handle the anticipated current load and to keep the length of the cable as short as possible. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Grounding is the process of connecting electrical equipment and wiring to the earth to provide a path for fault current to flow back to the source. Grounding helps to protect people from electric shock and to prevent damage to equipment in the event of a fault. SC cable typically includes a grounding conductor, which is a bare or green insulated wire that is used to connect the equipment grounding system to the building's grounding electrode system. Overcurrent protection is the use of fuses or circuit breakers to protect electrical circuits from excessive current. Overcurrent protection devices are designed to trip and interrupt the flow of current when the current exceeds a predetermined level. It is important to select overcurrent protection devices with an ampacity rating that is appropriate for the SC cable and the circuit it is protecting. Conduit is a rigid or flexible tube that is used to protect electrical wiring from physical damage and environmental factors. SC cable can be installed in conduit to provide additional protection, especially in areas where the cable may be exposed to physical abuse or corrosive substances. The type of conduit used should be appropriate for the environment in which it is being installed. Cable trays are open support structures that are used to support and route electrical cables in commercial and industrial facilities. SC cable can be installed in cable trays to provide a neat and organized wiring system. Cable trays can be made of metal or non-metallic materials and are available in a variety of sizes and configurations. Cable ties are used to bundle and secure electrical cables together. Cable ties help to keep wiring systems organized and prevent cables from becoming tangled or damaged. Cable ties can be made of plastic or nylon and are available in a variety of sizes and colors. Connectors are used to terminate electrical cables to equipment or other wiring. Connectors provide a secure and reliable electrical connection. The type of connector used should be appropriate for the type of cable and the equipment it is being connected to. Wire nuts are a type of connector that is used to join two or more wires together. Wire nuts are typically used in residential wiring applications. The size and type of wire nut used should be appropriate for the size and number of wires being joined. Lugs are a type of connector that is used to terminate large conductors to equipment or other wiring. Lugs provide a secure and reliable electrical connection for high current applications. The size and type of lug used should be appropriate for the size and type of conductor being terminated. The inspection of SE cable is an important part of ensuring the safety and reliability of electrical systems. Regular inspection should be conducted to check for signs of wear, damage, or deterioration. Inspection should also include checking for proper installation, support, and grounding. Any problems that are found during an inspection should be corrected immediately. The maintenance of SE cable is essential for prolonging its lifespan and ensuring its continued safe operation. Maintenance tasks may include cleaning the cable, tightening connections, and repairing any damage. Maintenance should be performed by qualified personnel who are familiar with the NEC and other applicable standards. The troubleshooting of SE cable can be challenging, but it is essential for identifying and resolving electrical problems. Troubleshooting may involve using a variety of tools and techniques, such as visual inspection, voltage testing, and continuity testing. Troubleshooting should be performed by qualified personnel who are familiar with electrical systems and safety procedures. Safety precautions must be followed when working with SE cable. These precautions include wearing appropriate personal protective equipment, such as gloves and eye protection, to energizing the circuit before working on it, and using insulated tools. It is also important to be aware of the potential hazards of electricity, such as electric shock and arc flash. The proper handling and storage of SE cable is important for preventing damage and ensuring its longevity. SE cable should be stored in a dry, protected location. It should be handled carefully to avoid kinking or bending the cable excessively. SE cable should also be protected from exposure to sunlight, chemicals, and other harmful substances. The disposal of SE cable should be done in accordance with local regulations. SE cable may contain hazardous materials such as lead and PVC, which must be disposed of properly to protect the environment. Contact your local waste management agency for information on how to properly dispose of SE cable. The selection, installation, maintenance, and troubleshooting of SE cable require a thorough understanding of electrical principles, the National Electrical Code, and safety procedures. It is important to seek the assistance of qualified personnel when working with SE cable to ensure the safety and reliability of electrical systems.